Okay, I mean no disrespect to anyone. Right at this moment, nobody understands the nature of subatomic particles. At Fermilab, they've seen them, but they've seen them from giant collisions. Well, we have seen the identical same particles from light collisions, not from proton collisions, which are, protons are made like this. And they smash together, and all these little bits go flying everywhere. And one of them will be a point particle, one of them will be a fixed particle. They've seen them, they know that. There'll be a ton of these all over the place, but we actually got them out of light, and this is how we saw this. And now then I'm going to tell you why nobody understands how electricity works. Like I said, you might have to go back and forth to be sure you understand what I'm showing you. I am saying this little black particle here is the same as this. This is the light going this way. This one's glowing more because it's pushing through. It's the one that's the glowy pusher. The blacks have no interaction whatsoever, none. They don't interact. All they want to do is be attached to white ones. What we did was we forced that light pulses, which means, and I show you that particle wave duality is this. It's the particle and a wave in front of it, which is the magnetic field, pushes this one out of the way. All right, very simple. Very, 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 very simple. Particle wave, no problem there. And then the black and the white can separate. This I never knew. That was a real shocker. These are glued together, but you can separate them. There they are separated right here. That shocked the hell out of me, I got to be honest with you. And anyway, this is fusion right here, fission. We broke the particles apart. You see them up here, they're stuck together. So that's fusion, fission. And they just come right back together automatically, instantaneously, once they leave the Venturi. And in the midst of that, all of this is concussive, explosive energy. Anytime you have concussive, explosive energy, you have white and glow, and you can use that. That can be used to do work. That is power. I'm going to tell you right now, that is a hell of a lot of power. And if it's correct, and these muon and electron neutrinos, when they recombine, you're in the trillions of electron volts. In order to shoot this light out here, and here we did nothing extra. So we shoot the light. Let's say it takes 100 million electron volts to shoot the light we need. If we get trillions out of here, that's what they call an increase of energy. And what is that going to do? We put it right into some type of a solar harvester, similar to a solar panel, and collect this extreme amount of energy, filter it through our devices to its ground, so it comes back together with the black. And by that time, you got energy coming out of your ears. And no infrastructure to support it. It's just like a couple little chunks of semiconductors. You know, solar panel, we know what that is, just a flat panel, little bitty one. These would be tiny things. You'd have a hell of an extreme laser and just a Venturi. Solid state, into some capacitors and batteries, whatever you wanted. You wouldn't need much of that though. Right now, there's a big issue with these batteries. They're very expensive, and they are, you know, they're a little bit, well, you know, they have their issues. Let's just go with that. All right, can we actually see light? Yeah, you can. And they call it a wave-particle duality. Well, sometimes they act like particles, sometimes they act like waves. Well, that's the wave. But what's going on is there's a particle behind here. This was created by this laser. Bip, 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 bip. And this stuff here, right here, is being accelerated towards a Venturi. I'll show you all this in a second. But what's exactly happening now is this is the particle, and out in front of it is the wave, because it's the magnetic wave. And watch, here's how it reacts. If I push this particle like light, well here, let's go the same direction this one's going. Alright, I'm dropping things all over, hold on. This one's going in this direction, so will we. Alright, can you see that? Alright, now what are we going to hit? More of these particles that are in the air. These are the same things. Everything's made out of these. So they are attached to the gases all around. This is going to push against that. When it does, it glows. Push to shove makes glow. Watch. You see it? Particle, wave, duality. Explain. Now, how fast is red compared to green? Not very fast. You see that red right there? You see the distance in between the waves? All right, that's the green. That's powerful, and it's much more powerful than the red. The green is, however, the exact identical particle. It's just much faster. And this, again, is exactly how they manifest themselves. You never would see these particles until they're getting ready to explode. Back here, you can hardly see them. Back further than that, you don't see anything. They don't have that concussive value yet. Here, they're stacking up against the Venturi, and here they just explode. They fall into pieces. All right, well, these are the two particles. There's the black one, which is just rolling around the outside. Can't get through the Venturi. The white one squishes down and runs right out of there and comes out and showers. I don't see any, there's no mystery here. The black one stays exactly the same size as a fixed particle, exactly what Don Lincoln says in What's the Point? Point particles. This is a point particle. It goes down to nothing. This one is a fixed particle. It stays the same size, same mass, same everything. It's gravity. It's dark matter. It's what they've been looking for forever. And it's simply attached to light. It's just part of the light. They just never saw it before. And I'll show you why. Because in the subatomic realm, when you're down here in the light realm, where we did this, we can divide it and see it divide. Otherwise, you never see this. Because once they become atoms, all this dark matter goes into the center. The white ones, they're separable. They can separate. The white ones will go around the outside, pushing the darkness inside. And I can show you that actually happening in the Russian space experiments. Okay, I am terribly sorry. I don't know where I am in this presentation or if I'm showing you this yet. However, this is plasma in space the Russians put into a vacuum chamber. Plasma means you have extra charged particles. They're extra. So the glowy ones are the plasma charged. They push their black particles right into a ball in the center because those are extra black particles. This is what a black hole is. And this is what happens in space. Every galaxy has a core like this of a black hole eventually when it gets big enough. And these continue to keep crunching and forcing it in. And then these are the swirling arms of the galaxy because everything's moving through space, it appears. So if I showed you this already, well, there it is again. Okay, get ready, you're going to school. This is all new. Electron flood model. It's all dipoles. Dipoles means you got a positive and a negative. And here they are. These are the ones that Don Lincoln and Fermilab and everybody sees is the black and the white. But they're separated, and they call them the muon neutrino, which is the black one, and the electron neutrino, which is the white one. At Fermilab, Don Lincoln calls it the fixed particle, the black one. Never changes size. And then the point particle, which can get big and small, and he says there's nothing there, really. It just has a magnetic field. Now, one of these I call an electron. We've never seen the black part. Nobody's ever seen it before. The only time it's ever been seen is because of this experiment right here. This is the only time in history the black part has been completely separated from the white and visible and totally separated. And I can show you that it was not separated. Right here, it was not separated. Just before it hit this little cluster. Here's what it looked like before. I think I showed you this, or I will. This is what a photon is. And they're not separated, they're glued together. Now, when that thing hits virtually any surface, every surface has electrons on them, and the electrons always float to the surface. It's like they're always going to be on the surface tension of everything. And inside will be the dark matter. But on a subatomic level like this, where we're underneath an atom, it just bounces. Here's what the new model is, and they're all dipoles, electron flood model. So there's nothing but electrons, nothing but electrons. And this is what I call an electron. It's back to back. It's positive, negative. Could think of it that way. two of these back to back, like two little bar magnets, makes a photon. And a photon is basically a neutral particle. It'll bounce. That's why we see them. They come up, they bounce back. Like the same light is hitting this, is hitting this, is hitting that color, this color, that color. Why? Why are we seeing all these different colors come back? Same light's hitting it. Well, because they have different radiation values. In other words, one will bounce it back harder, one's harder, I'm hitting it harder, whatever. They're coming back in a different frequency. One's going to be very long, one's going to be coming back. Blues are typically anyway. So that's what a photon is. Atoms, however, are crust of the red glowy matter, or if it's green glowy or whatever, and inside is where the dark matter is. Now, I believe the dark matter will completely fill that void. Or it may not. It may. This is where it gets confusing. I don't know. But I'm going to tell you what. I'm almost 100% certain, as I will show you, that these internal spaces fill with a vacancy. Now, molecules, depending upon the frequency of the number of particles within them, create matter. Matter is just different quantities of these electrons. This is where it gets confusing, because why do they lock in at different quantities? And they are at different quantities. What we always thought was a proton is not one proton, it's 1,835 electrons. And a neutron is just an equal number, which means 1,836. So there's no attraction, no pull, no shove. So a proton wants to grab onto another electron. But when you get in close to the nucleus, and the nucleus has enough core surrounding it of white ones, it'll say, no, you can't come. And he says, I want to come. I said, no, we're all white, and we don't like the other white guys coming in, so you stay the hell away. But you can stay that far away, which is how many distance is called angstrom units in there. You can stay out there. I know you want to come in. We'll push you. You shove back. And here's exactly what it would look like if it was happening. All right. Here we have a chunk of matter, and it is surrounded by these white particles. They will be surrounding all of the internal part, whatever this is. All right, can you see this? No, you can't. All right, this is the difference between light and matter. Light is strictly the smallest particles there are, and only two of them attached together. These are electrons, an electron here and an electron here. Nothing more than a bar magnet. And this black one is almost entirely the mass, and it never changes size. You see it? It's what they call at Fermilab a fixed particle. Now, this would be the mass of something that light particle was smacking into. And here's the way it works. It comes up and it bangs into it, and it pushes it back, you see? But it don't push it this far. It can stay there. That's what's called quantum. That particle, that electron, which is just one of these, says, I want to get into where all you guys are in the middle, because this is going to be filled with black in the middle. All right, and it's going to be a crust of these white all around. And they'll say, no, you got to stay there. You can't come in. We got enough white guys around here, so you can only come that far. And I say, oh, well, how about over here? I say, no. How about over here? No. How about over here? No. And they'll surround it in an evasive number of electrons. And it's called the rule of 8. We're not going to get that deep into it right now. It gets deep. But it's not, it's just simple once you understand. It's just nothing more than pushing and shoving. So I don't know if I showed you all this yet, but you're going to see it again if I did. The electron, which is the muon neutrino attached to the electron neutrino. This is the glowy, pushy, what they call a point particle at Fermi, and this is the fixed particle. It never changes. And these are two of them together make a photon. Photons bash into other little particles here, and they create light. And an atom is just nothing more than a collection of these. And what will happen is the red particles, or the glowy particles, which are the electron neutrinos, will surround the muon neutrinos. They get pushed to the center. I told you I was going to show you the one from Russia. Let me show you that, because that's how molecules form. And it has something to do with the frequency of the number of particles that are together. And at that time, they almost make a bubble and they lock in. And then they're pretty solid. They're pretty solid. You can, if you shake the hell out of them or force more electrons into them, they'll change sizes. They'll burn. They'll smoke. The particles will no longer adhere the same way because you're forcing more electrons in. That's what energy is. When you put energy into it, you cook it. You burn it. You change it. You destroy it. You change it for one way or the other. All right, it's taking on electrons or it's losing them. When you're in your steady state, you're just sitting there nice and cool and everything's good. What do you think is heat? What do you think is heat and cold? Heat and cold is nothing more than extra of these. There's extra or not enough. And when you get into absolute zero, it means you have absolutely zero extra free electrons. There's none. There's none. So now it's absolute block of solidness. And then if you put electricity in there, there's nowhere, they want to just zoom, they just go flying through because that's called superconductivity. There's just nothing there to stop them. But as soon as they start to flow, they'll start to push back. And that's what resistance is pushback against. It's this. That's what resistance is. I mean, it's really, because it breaks down to very, very simple stuff. Once you understand the nature of what the nucleus is. The nucleus is not one giant proton. You see, this is the nucleus right here, a proton. And a hydrogen, and then one little tiny electron out here, a little bitty tiny. And this is all positive and this is all negative. No, it's not that way. And then they say if there's neutrals, neutrons, they're almost identical to the protons. But guess what? They have exactly the mass of one extra electron. I'm not kidding you. It's like 0.005485 atomic mass units, something like that. A little tiny amount of it. This is just what it is. You just add one more electron and you're into a neutron. And it's hard for me to believe that they don't understand this. It's very, very hard. But I can show it. So if my problem is to be able to see this and show this and demonstrate exactly what CERN and Fermilab are showing. This is CERN and Fermilab up here. And they say, well, let me just show you so that, I don't want to put words in people's mouth, but I've been trying to communicate with Don Lincoln from Fermilab for a long time. And at first he was a bit receptive, and then when I had just undeniable evidence, he says, I'm cut off. I don't think that's right. That's taxpayer money there, my friends. Okay, my outstanding friends, it's going to be a fun time for Roger today. What am I talking about? I claim that I am literally the only one on planet Earth that understands the subatomic nucleus. I point you to this article by Don Lincoln from Fermilab, 2013, and he said there's a black fixed particle and a point particle that they have found, and they're the tiniest particles they can find. Here it says, in summary, extended particles have a fixed size, that's the black one. Although they might have a fuzzy edge, point-like particles are mathematical abstractions with zero size. But even zero-size particles have an extended effect due to the effect of the field surrounding them. It's a very good article to read. He understands. These are the two particles they can find, the smallest ones they can find. Is this black one never changes size, and this little white squishy one, it can be virtually any size or no size. Exactly what we found. Okay, here's what's going on. This is the fixed particle that never changes size. There's only one size of the muon. This is the electron neutrino, and it can go any glowy size. This has that red border around it. He shows these other two little bits. There's nothing to do with reality. Now, what is that? What we found? Well, it's the exact same thing. Here's the two black particles. All right, these are the muons. Never change size. These two are the glowy ones. Now this one is glowing a lot because it's banging into the particles in front of it, because this is going forward this way. So this is becoming charged up. This one's diminishing in charge. When this gets so fully charged that it's too much push to what's in front of it, it will flip to the back. This one will come in the front. That's what's called the Muon Wobble. That's this particle, same particle. And it'll just keep going like this, rolling down the road. And the red is much less rolling than the green. The green goes, the red just sort of rolls, and the blue goes. Now, that's what light is. That's a photon. Now, what we did, here's the problem. At Fermilab, they take what they considered were protons, big chunks, which are protons, smashed in here, and they fell apart into 1,000,000 billion pieces. But they weren't one of these, they were these. They were 1,839 particles together at the same time, makes one proton, or 1835, I think it is. And anyway, they smash, and it is everywhere. So all they can find these particles, but they have no idea where they came from. We started with light. We started with light. They're seeing the light come off it, because that's the smallest particles there are. But we started with the smallest particles, and then we did this. We divided the black from the white, right here. Hallelujah. Well, what am I going to say? That is the, they talk about God particle. This is like half a God particle. I don't know what you want to call it. The black is the muon. They say they have seen this happen, but they can't do it like we can. We can just do it, squirt it like this all day long. So we created the muon and electron neutrino pair, the black and the white, and then said blacks stay this side, whites go through that side. You go gate 1, you go gate 2, and they go around. And somehow there must be extra black ones out here that just jump right in, because right here they just slam into reality land. But in the meantime, the energy is just staggering. You wouldn't even be able to see this hardly if it wasn't for the fact that it's accelerating. And this Venturi, because way up in here, there's virtually no activity going on at all. I've spent a lot of years looking at this, and I'm pretty confident of what I'm saying. And I need somebody in the academic realm. I don't care about any glory or anything, but the one that should be taken well care of is Rob Warren. He's the one that spent all the time doing this. No money involved, no hope for glory or anything. Now, trust me, he's a very, very quiet, nice guy, and it's just not right to let this sit fallow because somebody can't get a Nobel Prize or something because somebody just normal did it by accident. That's just not right. Anyway, that's the problem I'm having right now, is trying to, this has been a lot of years. It's been 7 years now. I've been showing this to everybody. I even went to the University of Geneva through Coursera, and I presented this to professors. They not a single pushback. They said they'd follow me online. I said, well, why don't you guys do this? Nope. They work with protons. They want to break a proton and say, here's what a proton is made of. Well, I can tell you what a proton is made of. It's made of these. 1,835 of these, a black and a white together. 1,835 in a ball like this. That's a proton. And then as you bigger, they're just more and more complex. And that's when you start to get into the periodic table. You get more and more, it's just bigger and bigger ones. That's a 1, that's supposed to be 2 protons. And they go up by protons, but then they throw in a whole bunch of neutrons because they have no way to account for them. It's totally misunderstood right now. And I'm going to tell you this right now. I'm the only one on planet Earth right now that understands subatomic particles. If you think you want to debate me, you want to discuss it with me, I'd love to. I'd like to have a platform where somebody of esteem will come against me. That's what I want. I want some big shot. I don't want somebody that just says, oh, this guy's stupid. I want somebody to say, yeah, let's show the evidence. I'm showing this is deadly stuff, man. Now, this whole thing started today because of Veritasium. This is Derek Mueller, and I've been trying to get through to him to discuss. He comments on every single thing there is in physics, and I like the guy. He's very good, very personable, and it sounds like he's really interested in these answers. And I have some things to discuss with him. I may be wrong. He may be wrong. That's what science is all about. That's what research is all about. But anyway, that's how I got started, because he's talking about the big misconception about electricity. They don't even know what moves in electricity. They have no idea what even electricity is, because they don't understand the nature of the atom's nucleus. Heat is nothing more than extra electrons. Just like that. That's an electron in my world. One side is the glowy part, and this side is the not glowy part. And that side will break off and go into a big ball in anti-gravity. And it'll be surrounded by its white counterparts. It's just nothing I would have expected, but that's what happened. I showed you how the ball of blackness goes, and they say every galaxy has a black hole at the center. I understand why now. You see this? This is our universe, our space in our solar system. This is the moon obscuring the disk of the sun. So what it is, it's a solar eclipse. What is this? This is the radiation of the sun and the patterns. Well, what can we make from the patterns? You're seeing a real hot zone, hot zone, hot zone. These red spots are hot zones. You're seeing straight up and straight down on the poles. So this must be the poles. Spinning in this direction. Its atmosphere, and the sun does have an atmosphere, and the corona out here is where its atmosphere edge is exactly like the ionosphere in our atmosphere, I'll show you in a minute, is scrubbing as it is spinning through space. This is the impact zone, and this is the slough back zone. So these don't glow. These glow. These just trail. But these particles leave. They don't come back. This is what comes down, hits us, and goes all through the universe. Now, a brown dwarf, it's scrubbed hard enough to make these things all into dust and nastiness, and they get out here, but they're just not radiative enough to go away in extreme quantities. I mean, I'm sure some does. Because like we have the solar wind is nothing more than the exact same particles it is in your barbecue when you cook a steak. Same particles are in space. And the astronauts say when they go on spacewalks, they come back, they take their suits off, the suits smell like steak. And that's because it's all biology scrubbing through the universe. As far as I could determine, there's not one single thing in the universe that was not from biology. That's all I can say. And there was giants here, creatures on the earth that just absolutely staggering size. I mean, the dragon in Morocco is 1,100 miles long. All right, listen. Get your friends, get together and sit down, get your Google Earth out, and home in here, or Mauritania, Morocco, and all that, and see what you see. See if you see a big fish. Take your time. You got plenty of time. I'm not going to dwell on this. I've seen hundreds of videos about this. These are the scales of the fish. This is his top fin. The eyeball is right there. This is just something, I don't know why it's there, to be honest with you. I haven't looked at it close enough to make a big determination, but all I care about is seeing that it was attacked by a dragon that spit this on its back, and it ate right into its blood vessels. You want to see flesh and tissue? That is what happens to your flesh. All right? This is the artery coming down, bringing blood down. And all of these little things are blood vessels. These are blood vessels. You see that? This is blood coming down to service all of that tissue. This is not just accidental. And that happened right where he spit on the back of that fish. You see it right here? Right here. That's where it came down and finalized its attack. And it came right out from the mouth of this dragon's head. Dragons have a big bump on their nose. They have a couple of whiskers coming down here. They have a red fiery eye. They have a flashy thing that runs down the side. They have big long necks. They have scales. Let's see if we can find all these things. All right. This is the dragon venom, and they appear to emit from these beards. The beard spits out all that dragon venom. You see, that stuff is nasty as nasty gets. You see, they're hard to see, but this is one beard part, and this is the other beard part. You see it? And it appears to spit right out of there. Now, this is the red glowing fiery eye, and that runs straight back. That's exactly what it says. His red fiery flaming eye. Now, all of this stuff from here down, that's all run off of blood. All right. All of this is effluent. Effluent means it's just like the body gases and oils and all that stuff leaking out after you die. It's just, you go to autopsy pictures of somebody who's been dead for 2 weeks, they pick them up, it's the same thing. Now, here's all the dragon scales. That's his throat. These are all the dragon scales. This is that flashy stuff that you see on the dragons in the parades. You see it running right down his whole neck? It's not just accidental. All right, now, it ran right here, he's had his throat cut. And this is where he bled out and died in the desert, apparently. And this is, when you see this green like that, that's blood. That is where blood meal is what they feed to make plants grow extremely green. And you can see all the red blood and the black blood. This is all, that's mud fossil stuff, fully understood now from my research. Gee. Now, here's the legs. You see the legs here? If you look up in the library of Apollodorus, they talk about Typhon, and they talk about his legs, his thighs being like a human, and then turning into coils that wrapped all the way around here, all the way back up. This thing takes up almost all of North Africa, the whole top of North Africa. It's absolutely astounding. And it was attacking this fish even with these coils. These are not just mud. I thought they were at first, but they're not. They're coils. And if you look down at the actual fabric, it looks like just, what do we call it, sandstorms, but it's not. This here is hard to, this might be eroded so much you can't see it well. But over here, let me show you where it's very easy to see. And it's way out on the periphery. His legs come down way out to here, all the way around. And that's exactly what it says. It covers all of Africa. Look at the material this is made out of. All right, if you took that picture right there to a tanner, somebody that did tanning of leather, and said, what is this? They would say, that's some kind of leather, some kind of hide. All right, and then they would take it and they'd roll it flat and make it into a jacket or something. But this is what it is. I'm telling you, the world is just as crazy as it can possibly be at this moment. So, I'm not going to hold my breath, but I'm hoping I hear from Derek Mueller or somebody from PBS station. They're always talking about physics and light and all this business. Or I'd love to hear from Don Lincoln at Fermilab. I can be respectful, but it's been 7 years. And I contacted him when I first did this. I said, I found your particles, man. And the Russians have created this black hole in space. And he sent back something that was not, it wasn't polite to my way of thinking. And I understand that I was like invading everybody's territory. But at this time, this was all done. This was all complete. I showed dark matter. As a matter of fact, I had just done videos about dark matter being light in space. Because it is. Dark matter is light on its way to Earth. It's coming with the light particles. They're a charged carrier. The particles not separated, I don't believe, in space. When they start to congeal, yes, we saw them create the black hole. Just a natural thing that happens. All of that black goes to the center, exactly like the Russians did in their vacuum chamber. All right, somebody get a hold of me. Let's discuss electron flood theory. I can't get anybody in any university, even after going to the University of Geneva. I can't get anybody to respond. Why? What the hell is this all going on? I think I've shown some pretty solid evidence. If you think I'm wrong, say something. If you think I'm right, give me a thumb up or something. Something that says, you know, or try to get a hold of Derek, try to get a hold of any of your professors and say, why is this guy wrong? So far, they say get in the back of the class and don't say any more about it. That's what I hear from people. They don't want, they just absolutely refuse to engage. Because this is as disruptive to your everyday thinking as it could possibly be. Everything that I found, the mud fossils, that is even worse. I'm sorry. We are just dictated to, and if you don't repeat what you're dictated to, then they tell you you're stupid. And then you don't get a good job, and then you fall in line. Well, didn't work for me.